All right, this one is in an unusual form. It looks like a proportion, and the first thing we want to do is set it to 0, but before we do that, we should try to clear fractions. And so what I want to do is just multiply the two denominators, so I get 5x, and multiply that on both sides. And the 5's reduce on the right, the x's reduce on the left, and I have 5 times 3 left on the left, and 8 minus x, which is that numerator, times x. So I can just distribute this x here and then multiply. So I have 15 equals 8x minus x squared. Well, now I have an x squared, so I kind of have a better feel for what I've got going on here, but I do need to set it equal to 0 so that I can use all the methods I've been working on. So I see that I have a negative x squared. We worked on some of these before. I need to move that negative to the left, so I'm going to add x squared, or I don't have to, but I choose to because I like having a positive x squared, and subtract that 8x from both sides. So these cancel. On the right, I just have a 0. On the left, I'm going to put it in order, x squared minus 8x, and then plus 15. Now, at this point, I want to factor. So I'll use sum equals -8, product equals positive 15. And I know it's 3 times 5. And I know I need a positive product, a negative sum, and so I know I need both of my factors to be negative for that to work. So -3 times -5 will give me positive 15, and when I add them, I do get a -8. So -3 and -5 are my factors, x minus 3, x minus 5, set to 0. Set each factor to 0. That's the 0 factor property. And x minus 5 equals 0. And I hope you can see that your x's are going to be 3 and 5. And then we can check them. So I have 3 over something equals 8 minus that something over 5. And I'm going to try my 3 first. So I have a 3 here. And when I do that, then I have 3 over 3, that just gives me 1. And 8 minus 3 is going to give me 5 over 5. And 5 over 5 is the same thing as 1, so that's a true statement. And that was checking my x equals 3. Now I want to check my x equals 5. And so I'll do 3 over my x equals 8 minus whatever my x is over 5. That's my original problem. Plug in my 5's this time. And then simplify, so I have 3/5 equals 8 minus 5, which is 3/5, so that one is correct as well because it comes up to another true statement.